And the guy running it is a history guy. He keeps saying like 100 pages of reading every week.
I remember in the first year for history, you might say, oh, it's a light read, but well, you can get through it in a weekend.
I got that when it was a gift from my friends back home, and it's such a slog. It's like, that's where the first 100 pages just with no wheat.
I bought it because I thought, maybe I'll read it. It'll be a light read. Yeah. All I saw was the cover on Amazon. I was like, absolutely, a light weekend read. I haven't touched it since I bought it. It's been sitting on covering up half of my shelf.
Yeah. I'd like to see what went through your head the second the book actually
It arrived and it was a hunk. It was literally like,
how did you think it was?
don't know, I thought it would be a few pages, like a paper kind of thing.
First foundation of economics, just a bit of a pamphlet.
Yeah.
The map you get when you go to a theme park.
Whole foundations of economics are just sitting on my shelf. And I didn't even buy the simplified version. I thought to myself, this is
Simplified version?
Yeah, apparently, where it puts it in like real English. that E wrote back in the right covers when it was written. I opened it up, I read page 1. I used to read it to my ex-girlfriend when she couldn't sleep. Because I thought to myself, I will put it to bed. So I started just rattling on and it was as hard as reading, because I thought to myself, I'd try like classical literature and things now. So I bought a Dostoevsky book. And it's not as difficult to read as that. It was just, I'm not doing that.
Southern Russian literature is really hard. I enjoy, like, the first year I read Notes from the Underground by Dostoevsky, which I really recommend. It's really good book. And Death of Ivan Ilyich by Tolstoy. They're both actually short books.
Oh,
You're not going to
okay.
get it's not like a Brothers Karamazov. I have not read that one for good reason. But, yeah, they're so, I don't know how or why, just very dense.
Yeah.
Oh, right.
You missed a lot of the classes. Is it the first time you're here?
I've been doing an internship. It's cleared with my academic supervisor. So
Sorry?
I'm packing up online.
Sorry?
I was doing an internship,
Yeah?
which I cleared with my academic supervisor.
Okay.
So I haven't.
I'm sure you've been working on it, but it's very difficult to manage with this material without coming to lectures. So, well, if you need any help, let me know. I seem to misplaced the sheet that we were using. I probably left it in the class the last time, the other one. And I go and try to find it after today's lecture. You could put down your name at the bottom. So I know that yesterday one person had submitted the work. I hope those of you who are in class have managed to make a submission. Code for today is 389111. Right, questions before we start? It's starting slightly late, should be all right. Any questions? No, all right, okay. So we're going to start on the second half of the module, so to speak. And we will spend a number of lectures, or more than half lectures, 2/3 of lectures, on a model that I should introduce there. So in terms of what we've seen so far in monetary models, both the models of money that we have seen are quite special, really, because that's what the model does. Develops on certain aspects that we believe are relevant. So the Gromov-Yunez model was based on the idea that money is used for transactions purposes. And that can actually mean various things. There it means something quite specific. It means that the goods that you sell that bring you revenue, well, that revenue is not available to you at the point in time at which you sell. It's available in the following period, which is quite a realistic way of modeling things. And our job there was to see what the consequences of that are. That was the Gromov-Yunez model. In the Bewley model, you felt a need to use money because you couldn't borrow and lend directly, and your endowment stream was uneven. So what you receive today and what you receive the next day are not the same. The model was set up so that things worked out really well, but that was the key feature. Now, another aspect of money, which is completely standard in terms of saying why we use money, is the so-called lack of double coincidence of wants. So you might have 5 people sitting in a room. Let's say they're sitting in a circle. It's the easiest way to explain it, but sometimes people get stuck thinking that's the only way to think about it, but it's not. And suppose the good that I own is one that the person sitting on my right wishes to consume. However, the good that that person owns is not one that I'd like to buy. I don't care for that good. I'd like to buy the good from the person who's to my left, who doesn't care for my good. So in some sense, these 5 goods need to go from one person to the other around the circle, counterclockwise in this case, and there'll be no trade if you don't have any means for converting what you gain by selling, so that you can hold it till such time as you're able to pay the person that you want to buy from. So that's a very simple way of thinking about the lack of double coincidence of wants. So there are 2 people and they wish to trade with each other. So if that does not happen, and it's quite reasonable to say that in general that's not going to happen, then there is a role for money. And the model that we will develop essentially builds on that feature, although it puts in certain other elements which make it a model of trade over time. And because of that, in some sense, you can interpret it in a different way, and that's what we will be looking at and studying. Now, compared to the 2 other models, the Gromov-Yunez model and the Bewley model, the really nice thing about the overlapping generations model, at least in the form in which we will be seeing it, is that the individual's optimization problem is very simple. Very, very simple. Almost, not trivial, but very simple. Because of which, it's at that level, it looks like it's almost a triviality to study, but the model is very rich. We will focus on a certain class of simple equilibria, but the model is capable of generating much, much more interesting phenomena, which we won't be covering here. Yeah. So the idea is, so this is the overlapping generations model. So this is, okay, so there is some dispute as to who it's originally due to. One people attribute to Samuelson. Samuelson, as you probably know, is considered to be one of the finest economists that the world has seen, together with Arrow and earlier people like Keynes first. But in the post-war era, one of the most influential economists, a very good economist, originally a student of physics. There is the claim that the French economist Maurice Allais, who also went on to win the Nobel Prize many years later, that Allais had also spoken about at least a similar model in his work. But one of the experts in this field, a very senior economist, was at York and a colleague of mine for many years. And he was quite clear that, although he read the original French, he thought the model was actually due to Samuelson. So just some background. It's called the overlapping generations model. Often called the OG But OLG is probably the better way to put it. Although it doesn't quite fall in the category of appropriate abbreviation, but even so. So time will go on forever. So time will start at 0, but we'll be careful with how we include the 0. That will be important in the way we do things, but you'll see that in a moment. Time goes on forever. There will be only one good at each date. Okay. And at each t, I should be careful here, at each t from 1 onwards. And you will see what the role of 0 is a bit later. Okay. So there will be one physical good at each t, and the good is perishable, there's no production. Your change economy, so that I'm not writing here. There are in 0 initial old ages. They play an important role in this framework. So initial old agents. So the idea is that they live for only one period. So alive and consume only everybody else will be alive for 2 periods. So the idea is that the initial old agents are, so to speak, born at t equals 0, and they capture the history of the economy. This is the idea. Okay, so there is a beginning to the world that we're looking at, and that beginning is captured by what the initial old agents bring to the economy. Okay, so you're going to say their endowment of the good at date 1 is 0 units. Keep things simple. Okay, they have a utility function. Given by U0 to indicate when they were born, which depends on how much they consume of the good when they're old. So the 2 indicates that they're old. This will match up with notation that we develop now, and how much they consume at date 1. So this will become clear when I put in the notation of the best. Okay, which is depends on just one variable. So this is simply an increasing function. They care more about the good. They'd rather have more of the good than less. That's what it says. Are you able to read this one back? Is it okay? And then at each t greater than or equal to 1, NT agents are born. Who are alive at t and t plus 1. So people live for 2 periods. Okay. So they're alive at t and t plus 1. Their consumption is denoted by quantities which we should write as C1t. So C, the 1 indicates that that's when they are young. T is the period in which they carry out the consumption, and C2 t plus 1. Okay, so the notation here will be important, so you want to make sure that you understand what you're doing or what I'm doing. You can use different notation, but that will confuse both you and me. So it's probably better to just stick to what I have here. This is the notation for this model changes if you look at other sources. This is not necessarily the best or the standard notation, but I'm using the notation that is used in the reading that you could look at if you wish. I'll try to, the development in class will be self-contained. The reading actually, I think, also ends up confusing people at some points. With their approaches, not necessarily the standard approach which I'll be using. All right, endowments. Again, we will keep this very simple. They will have Y units when young and nothing when old. This is extreme, but this is, in some sense, the simplest way to think about the model. References. Will be given by a utility function, sub t. Actually, they will all be identical, so I'll just keep the u0 there. The rest I will write without any time notation, subscripts. Takes two numbers that are non-negative and gives a real number. And it's nice in our usual sense, which I'm not writing on the board. It's increasing in each coordinate, so they like more of each good than less. It's differentiable. You can take derivatives and use Lagrange, etc. to work out first order conditions. And it's strictly quasi-concave, so that the indifference goes to gradient. So I'm not writing that. You have that in the handout. I'm not writing any of that. So now think about what's actually happening, right? So you can think about it as, I'm not putting a figure on the board. I could. But the idea is, take a simpler case, so to speak. Take the case where there is no change in the population. So there is, suppose there is just one person born at each date, including an initial group. So at any given date, you will have two people in the economy, an old person and a young person. That's it. Is that okay? It's a very simple structure. You have only two people in the economy. So we're going to start with that case and analyze it a little bit. So now, this is the simplest case where the population is constant. Okay. N0 equals NT equals 1. This one is without loss of generality. You can have as many people as you like, but let's keep it 1. Okay? So now what's your feasibility constraint? This is the first thing. Well, at any given date, how much do you have in resources? The old chap brings in 0, and the young chap brings in y. Okay? Is that okay? What do you use it for? You allocate consumption to the old chap at time t, so feasibility t. So the old chap's consumption at t is, using our notation, C2t, and the young chap's consumption is C1t. So this is the chap who's old. So he was born old at t, so born at t minus 1, and this is the chap who's young. Is it okay? That's feasibility. Shouldn't be a problem there. And what about a market structure? Okay. So the market structure is there is a spot market. For the good at each t. At each t from 1, 2, 3, etc. Right? Date 0 is simply used to identify the old agent, nothing else. All the action takes place from date 1 onwards. So there's a spot market for the good at each t with a price PT. There will be a little more. Okay? But let's put in what we actually will have all the time. Now consider the first case. Suppose there are no assets. So there is no way of transferring resources from one period to another. So the problem of a young agent, okay, the old agent's problem is trivial, but we'll get to that in a moment. The problem for a young agent, okay, is to maximize by choosing consumption when young and consumption when old, which we know is a two-dimensional vector. They will be maximizing their utility. Subject to what constraints? Well, when they are young, they have Pt times y as income, and there are no assets that they can buy, so they can spend their income on buying the consumption good on which they spend PTC1T. And when they're old, they have 0 as income since they don't have an endowment when they're old, and therefore they get to spend PT plus 1 on C2 T plus 1. Is that okay? Yeah? Now put yourselves in this person's shoes. Well, clearly you will consume nothing when you're old because you cannot. Not that you don't want to, but you have no income. So you must consume nothing when you're old. So your entire endowment will be spent on consuming when you're young. So the solution is trivial. Okay? Make sure that you understand why. I'm just writing it as wise. That's how much you consume. Is that okay? Please make sure you understand. This is important. Clear? Not clear to you?
Could you just say it again?
Yeah. So when you're old, that's your budget constraint. You have nothing as income. You can't consume negative quantities of the good, so you must consume 0. Right? So if you consume 0 when you're old, what are you going to do when you're young? Well, you'll consume your entire endowment when young. So that's the only solution. All right? All well? Yeah? So if that's the only solution, that tells you, we don't know if there is a competitive equilibrium here. That we don't know. We're not making any assertions. But this is telling you that in any competitive equilibrium, right, which I'm not introducing new notation for, no stars or anything of that sort. So the individual's consumption is Y0 for all t from 1, 2, etc. And therefore, by feasibility, the old agent's consumption is 0. So there is no trade. It's also called autarky. Let's just write it as no trade. Is it okay? It's completely obvious that you would wish to trade. Who wants to sit with, being very rich when you're young and starving when you're old? You don't want to do that. But given what we have, that's what's going to happen. If there is an equilibrium, there are situations in which there won't be an equilibrium, but that's a separate matter. That's not good. Something's bothering you. Go on.
If there's no consumption in the second time period for the old agent, surely that means we should, when we consider lots of people, we only consider when they're young. I mean, just
Can you speak a bit louder?
Well, if the older agent consumes nothing in the
Yes.
second time period,
Yes.
and all their endowments spent in the first period,
Yes.
surely we consider the population over time period T0 to
Yeah.
infinity. We only consider agents in their youth time, because we know they're never going to consume if they're older.
Yep.
So we're just looking at individual points, if that makes sense.
Even if you do that, what difference will it make?
It doesn't make a difference. That's what I'm saying.
Yeah.
Because when we're older-
So you have trading opportunities, but no trading opportunities are taken up. You have a market, a spot market each date, okay, and yet nothing's going to happen.
It's essentially similar to what was done before. We're just saying that they're not doing it.
Where did we see that before? Tell me.
With no, because the agent would have been alive for a long time period. But they consume their entire endowment in one period, and then the next agent's come and they consume.
Where did we see that?
Are you talking about agents who are patient?
Sorry?
Are you talking about agents who are patient or are you?
No, I'm just saying that if they consume nothing in the second time period, it's not really worth considering them in the second time period, because they consume their entire endowment in the period in which they're born.
You see, be careful. This is what so there are lots of things that I don't say in class, but in some sense I'm asking you to think about it. So if instead of y and 0, I made it y with something positive there, right? That wouldn't make much of a difference. You have the same argument. You see, the problem here is the nature of the budget constraints. So if I put in a positive number there, yeah, my consumption would be positive, but it would basically be my endowment. The point is that we don't trade. That's the key point. You can have positive endowments when you're old, but you still go home and eat your head. There are markets, but you won't trade. Now, it is the case that that happens because you have one good. If you have more than one good, and you have a variety of young people, then you kind of trade within those people, but there will be no intergenerational trade. The key point is intergenerational trade. That's what we're getting at. Okay?
Yeah.
So the simplest way to see that is by taking an extreme endowment and say that there is no trade, and with one good. Is that right? So there is no trade in what we've set up so far. Well, introduce fiat money. Now here there is something to be said. We're going to keep it simple and say that there is a positive amount of fiat money that the initial old have as an endowment. You could also say the initial old is smart enough to invent fiat money. We don't really ask how it comes about. We're simply saying, suppose it is the case that there is this thing called fiat money, which we defined earlier, right? Which is available in this economy. Now what? And we are not asking whether or not every equilibrium will necessarily have a positive price of money. There will be situations in which money never has value. We are not looking at those. That can happen. Okay? But we want to ask whether there are other solutions. So introduce fiat money, price 1 always. So we are considering monetary equilibrium. Right? So we're focusing on the case in which we're looking only at monetary equilibrium. Clear so far? Anything that you want to ask? Because now we'll start on the model. Now, the way we will set up and solve the problem will be the same in each of the variations that we see. So the key idea is not to memorize that, but to understand what the steps are. We will always have the same steps, but you will get different results because something or the other that's different. Okay? The best way to understand that is to not try and memorize it, but follow the steps to figure out what is it that we are doing. So now, I'm going to write it out as though I'm looking at a competitive equilibrium, but of course it's actually a demand problem. Okay? So the demand problem is the following. Made some changes there, but let's write it again. So now you want to maximize by choosing C1t, C2, t plus 1, and also the amount of money that you carry from youth to old age. You can also ask how much money would you carry from old age to the next period. And here we work as economists and not people who do economic theory and say, well, it's clear that you're not going to carry any money into the next period because you're dead then and you have no use for it. Okay? So we just not expand notation even further and write this as R3. I'm going to write it as plus because the amount of money that you carry, it being fiat money, you cannot carry negative amounts of. Okay? Maximize your utility C1t, C2t plus 1, subject to, well, we've already said these are non-negative, but now you get your restriction when young, it's PT times C1t is what you spend on the good, plus any money that you decide to transfer from one period to the next has to be less than or equal to PT times your endowment, which is Y, and P, T plus 1, one has to be less than, well, you have nothing as endowment, but you can spend the money that you carried over. Is it okay? Now, we can of course solve this with a Lagrangian, but it's simpler to simply substitute things in. The only thing we need to be careful about is we need to make sure that non-negativity is satisfied, but this we can check for later, which is the way we will do it. Okay? So, substitute and convert the problem into maximize by choosing MT. We want to make sure that it's non-negative, but that we will check later. So we don't impose this directly on the problem. It's written here, but our solution to the problem will not incorporate this. It will be checked later. U of, instead of C1t, I write it as Y minus MT over BT. It will be here, I write it as MT divided by BT. So our first order condition, which will be necessary and sufficient here, subject to making sure that my money holding and my consumption, etc., are non-negative, which we will do later. Just write this first order condition. So my first order condition in general is, well, I'm taking the derivative with respect to MT, so I'm going to write it as the partial derivative of u with respect to its first coordinate, evaluated at my point of interest. And then I need to use the chain rule, so I get minus 1 over pt. And then I get the partial derivative with respect to the second coordinate, again evaluated at my point of interest. On the board, it's going to be difficult for me to write all these things, so at some point I'm going to stop incorporating all the points at which we are taking the derivatives, but you should be fine. Times 1 over pt plus 1, again by the chain rule. And all of that has to be equal to 0. Please ask if something is not clear. Okay? Today, some other time, you need to make sure things are clear. Is it okay? Yep, this is the first order condition. So now that's an equation in 3 variables, MT, PT, and PT plus 1. Now PT and PT plus 1 are my exogenous variables. So I can solve that equation for the one endogenous variable, which is MT. Right? So solve to obtain mt as a function of pt and pt plus 1. Which is my money demand. You will have exercises to work through. And after today's class, you can actually start on the exercises. I'll work them out. The first problem set will be worked out next Thursday. Is that okay? So far, any questions? So what's an equilibrium? Okay, equilibrium is a set of prices P star T, okay, P star T for each T, one, such that what is true? Well, my money supply should be equal to my money demand, right? My money supply is capital M. We are looking at the case where there is a fixed amount of fiat money in the economy and it does not change. So my equilibrium condition is simply N sub T, P star T, P star T plus 1 equals capital M. Why? Because we have a fixed money supply. Okay, so in a variation, what you have on the right hand side will change. But here, it's capital M. Is that okay? Yeah? So now, how do I proceed? Well, it's very clear. That's my first order condition. Substitute. If we substitute into the first order condition, what do we get? So we get u sub 1 y minus, well, if the market for money clears, then each agent will be carrying m units of money, capital M units of money. But now I have to look at equilibrium prices. Right? When old, they will take those m units of money back to the market, buy goods at prices pt plus 1 star. Okay? You can write this in various forms, but just to keep things as close as possible to what we had earlier, 1 over p star t, sorry, minus 1, well, you can write it with moving it to the other side, and then u sub 2, again, y minus capital M p star t, capital M p star t plus 1, over p star t. Question?
Should the U2 be negative?
So I've put an equality sign there. So I moved this term to the right if you wish.
Oh, I see.
Or, I moved.
Just got
Yeah, that's it.
Yeah, makes sense.
Right. Okay? That object is called a nonlinear difference equation. So if you want to study the model in general, that's the sort of stuff that you need to work with. But we don't want to do that. We want to do something which is much simpler. Because for our purposes, that will show us what we actually want. So now we are going to focus on, and we've already done that in the other two models that we looked at, stationary equilibrium. In the Bewley model, there were no stationary monetary equilibria, so we looked at the next simplest thing, which was an equilibrium in which consumption took one of two values. But over here, there will be stationary equilibrium. Focus on stationary equilibrium, so that consumption, when young, is always equal to some fixed C1, and consumption, when old, is equal to some fixed C2. Now go back to the budget constraint. Wrong. I'm writing things out carefully. It's the steps that you need to bear in mind. If you change the problem a little bit, you will still have some form of this problem. Get the first order condition. You impose money market clearing, where what you have on the left and what you have on the right could be a bit different. Okay? You write it in that form. Say that you're going to look at a stationary equilibrium. What are the consequences and so on? Right? So from the budget constraint, when young, so we have C1T, write it the following way. Okay, write it. C1T plus MT over PT equals Y or Y minus C1T equals MT over PT. So making this more painful by stretching it out, but in some sense, you have to make sure that you follow. So, when stationary, consumption is stationary, you get Y minus C1 equals MT over PT. Define mu. This notation says I'm defining the value to be Y C1. Let's continue over here. At a stationary equilibrium. What's going to happen when I'm going to denote mu by mu star? Okay? And from the budget constraint, right? At a stationary equilibrium, what is true? Mu star will have to be equal to the market for money has to clear, and the price will be the equilibrium price. And this is true at each t. Is that okay? Step by step by step by step by step by step. Don't jump. Write it out, regardless of what people tell you. You're stupid, you're not stupid, you're doing it correctly. Do it carefully. Understand what you're doing. Don't skip steps, and you'll be fine. Skip steps, and before you know it, you don't know what's happening. Don't do that. Write down every step. You know, this is why I put this in. You do it a few times, and you will know how to jump, and you will realize where things have gone wrong. You go back, fill in any missing steps, and do it correctly. So, mu star equals m over p star. Hence, look at this. Prices must be constant. That's not always true, but here it is. Is that okay? Well, we're almost done, at least with this first setup, which is quite a lot. Why? Because now I can go back to my first order condition. So rewrite after substitution. So what am I going to rewrite? Well, my prices are constant, so they cancel out. And my equation becomes U1 Y minus M over P star T, but that's always mu star. M over P star T plus 1, so that's also mu star. Equals U2 Y minus mu star, and now I can solve for mu star. I've reduced everything to a single variable and I'm done. So I've written something over here that's incorrect. Sorry. I'm overused. Okay. What I was doing incorrect here. Is it okay? Clean. We will be doing a little more. Is it okay? Have you followed? Anything you want me to go over again? Anything that's not clear? Right? Now, the first observation, money is neutral here. If I double the amount of money, if I already have an equilibrium, then doubling prices will give me another equilibrium in which consumption does not change. So money is neutral. And yet, in the absence of money, my equilibrium was the endowment. Is money making things better? Well, we need to know what does it mean to say it better or worse. We have to get to that. Okay? Questions? Now, I want to talk about the rate of return and some notation. I don't know whether we can do much more today, but. So what is the rate of return on money? Money is an asset. Right? How much do you pay for a unit of money? How much consumption do you give up when you're young? You give up 1 over P star T. What do you get back in the next period? You get 1 over P star T plus 1 in terms of the consumption good. Okay? This is worked out in the handout using the budget constraints. It's just rewriting the budget constraints, which I haven't done here. Okay? I also haven't drawn any figures to show you how you solve the problem. I will in a moment. So the rate of return is 1 over P star T is how much consumption you're giving up. 1 over P star T plus 1 is how much consumption you are getting, and therefore it's P star T over P star T plus 1. Is it okay? Now, think about whether you can think of this problem as being one in which you actually have a single budget constraint. Okay, it's as though money is allowing you to combine the two budget constraints. So you can do that. If you do that, and let me put it on the board. Here to draw a larger figure. This could be any agent born at 19. That agent consumes when young and when old. The agent's endowment is Y and 0. And therefore, you can draw a budget line. If you have money, you can actually draw a budget line that looks like that. And you can ask what the slope of that line is, and you can work it out, right? In combining budget constraints, inverted commas. It is not negativity, but it's not negativity here. So combining budget constraints, you can think of it as PT C1T divided by PT plus 1 C2 T plus 1, right, is equal to PT plus 1Y. Okay, C2 T plus 1 equals minus PT plus 1 C1T plus PT plus 1. So the slope of the budget line together is minus this much earlier. This is just to tell you that you can apply the same apparatus. Okay? The book uses different notation. Okay? The book simply defines, you don't need to worry about it. The book defines VT to be 1 over PT. In other words, they set the price of the commodity to be 1 always, and they call 1 over PT the price of money. That's the way they work with it. And later they move to the PT notation. I just think the PT notation is completely standard with what we've done so far and in general equilibrium, so I'm going to use that notation too. I wanted to do a little more, but in the interest of time, I think it's best that we stop here and we continue to work. Okay? Because the next question is, all right, so we found an equilibrium. Does the equilibrium have nice properties? Okay, it's all right to say you're inventing money. Is it a good idea? And you show that yes, in this really simple world, it actually is a good idea. But you should not end up with the notion that it's always a good idea. Later models, variations, will show us when things work and things don't work. That's the key. Okay, so this was the setup to understand how to approach the problem. Right? We'll continue tomorrow. Thank you.